Good morning. Good morning. The session's problem is titled as petrol pump. Say a bunch of friends reached petrol pump or reached petrol bunk and there are n persons with n cars. All of them would like to get their tanks, their fuel tanks get filled. Okay, the fuel tanks are of different sizes. Fuel tanks are of different sizes. Okay, for example, so there are 10 cars with sizes of fuel tanks 1, 2, 3, 4, 5, 6, 7, 8, 9, 15. So these are sizes of fuel tanks or capacity of fuel tanks. Car 1 can take 1 liter, car 2 can take 2 liters, car 3 3 liters, car 4 4 liters, car 5 5, car 6 6, car 7 7, car 8 8, 9 9, and last one 15. Okay, so these are fuel tank sizes, right? Now in liters, to fill 1 liter it takes 1 second. It takes 1 second, and there are two petrol pumps. There are two petrol pumps. Any car can go to any petrol pump. Any car can go to any pump. Okay, so find out what is the maximum time required, what is the minimum maximum time required to fill petrol in all the cars. Okay, so cars can go to per bunk in any order. Is the problem statement clear? Is the problem statement clear? Say petrol pump 1, petrol pump 2. There are 10 cars with sizes 1, 2, 3, 4, 5, 6, 7, 8, 9 and 15. Okay. So any car can go to any pump. Suppose if first car goes to P1, then petrol filled is 1 liter. Assume that car number 3, 5, 7, 9 went to 1 and petrol pump 2 filled the petrol in 2 liters in car 2, 3 liters in car 4 liters in car 4, 6 liters in car 3, car 6, 8 liters in car 8 and 15. So what is its time? This is 9 plus 7, 16, 16 plus 5, 21, 25 seconds. So petrol pump 1 will take 25 minutes. Petrol pump 2, 6, 6, 12, 8, 35 minutes. So what is the total time required for all the cars to get filled? 35 minutes. Is this clear? Is this clear? Now second situation. 2P1 we have 1 plus 3 plus 5 plus 7 say plus 15. Now P2 workload is petrol pump 2 workload is 2 plus 4 plus 6 plus 8 plus 10. So test swapped. How much is this? 22, 27, 27, 31. This is 31. Okay. 31 minutes or seconds. How much is this? 17, 23, 29. Okay. So what is the maximum time required? 31 minutes. See, simply by changing the order, the task is finished in 4 minutes earlier. Okay. Now let us consider one more case. Petrol pump 1 took filled petrol, okay, in car 1, car 4, car 5 and then car 8 and car 9. Petrol pump 2 say 2, then 3 liters, then 6 liters, then 7 liters, then 15 liters. In this case, the totals are 27 and 33. So what is the time required to fill petrol in all the cars? 33 minutes. So what is the best sequence? What is the best sequence? What is the best sequence? Good morning. Tell me what is the best sequence? This is car number 1, car number 2, car number 3, 4, 5, 6, 7, 8, 9. The last one is car number 10. Here P1 has taken care of car number 1, car number 3, car number 5, car number 7 and car number 9. Okay. Whereas P2 has taken care of 2, 4, 2, 4, 6, 8 and 10. Okay. With this sequence, the maximum time is 35. Okay. So if this sequence is followed, in 31 minutes, petrol in all cars will be filled. If third sequence is taken, then it takes 27 minutes. Which sequence is the best? What is the better sequence? So please let me know what is the best sequence. First of all, did you understand this? Sumalata, Vijayasri, Priyanka, did you understand the problem? Here, second petrol bunk took 35 minutes. First petrol bunk took 25 minutes. Okay. So which one you prefer? Sequence 1 or sequence 2 or sequence 3? Minimum of maximum times. Which sequence do you prefer? So I'll tell you one more example. There are 3 cars. There are 3 cars. Car number 1 capacity is 10. Car number 2 capacity is 20. Car number 3 capacity is 30. There are 2 petrol pumps. To minimize the time, which sequence do you prefer? Tell me. If pump 1 takes first car and third car, what is the time required? 10 plus 30, it takes 40 minutes. Okay. If pump 2 takes second car alone, what's the time required? 20. Okay. Okay. So what is the overall time? What is the overall time required? Both pumps work parallelly. Say 3 cars with 10 liters, 20 liters and 30-liter capacity. Car 1, car 2, car 3. Okay. Now car 1 came here, get 10 liters filled. Car 2 went here. Okay. And car 3 came here. So total petrol taken is 40 liters, took 40 minutes. And this took 20 minutes. Because they are friends, they will wait till all the cars get filled. So when do they leave the petrol bunk? At what time do they leave the petrol bunk? At what time do they leave the petrol bunk? All of them arrive at once and leave at once. Even though second car gets filled, all of them will wait till third car gets filled. So they will leave the petrol bunk after 40 minutes only. Okay. Now take another example. Petrol pump 1, petrol pump 2. There are 3 cars, 10, 20, 30. Suppose 1 and 2 come here and third car comes here. Now at what time do they leave the pump? In this case, at what time do they leave the pump? 1 and 2 here and third here. What time do they leave the pump? 30 minutes. So which sequence is better? Which sequence is better? P1, P2, 1, 2, 3 are the car numbers. Case 1, 1 and 2 here, 3 here. Case 2, 1, 3 here and 2 here. And the times are 10, 20 and 30. Okay. Which case is better? Which case is better? Second case or first case? In first case, this is 30, this is 30. In second case, this is 40 and this is 20. Okay. Is this clear? So now we need to find out the sequence which takes lesser time. We need to find out the sequence which takes lesser time or minimum time. Now you tell me, what logic should I follow? What logic should we follow? Sumalata and Pranita, which is a better one? Ten plus 20 and 30. 10 plus 30 and 20. Which one is better? Here it takes 40 minutes for all the 3 get filled up. Here it takes 30 minutes for all 3 to get filled up. Okay. So which case is better? Do you wait till 40 minutes or you get the work done in 30 minutes and leave the petrol bunk? Which one is better? Okay. So tell me how to do it. Can you suggest me? See, there are cars 1, 2, 3, 4 and so on up to n. Okay. With times required varies from T1, T2, T3 and so on up to Ti. The last one is Tn. Okay. These are car numbers. These are requirements. There are n cars with n liters or n times. The logic I am going to follow is, please listen to me very carefully. petrol pump 1 and petrol pump 2, it served m number of cars already, and it served n number of cars already. Okay, so remaining are, so total minus m plus 1 are remaining cars. There are n cars. Petrol pump 1 already served m cars. Petrol pump 2 already served n cars. Remaining cars are n minus, these are remaining cars. Okay, so they are numbered from 1, 2 and so on up to say p. Okay, these are remaining number of cars. So total time so far is T1 here. Total time so far is T2. Okay. The next two cars are jth car and j plus 1th car are next two cars. So which car will be sent to P1 and which car will be sent to P2? What should be the logic? Already some cars are served here. Some cars are already served here. So which car will be sent to P1? Which car will be sent to P2? This is Tj. This is Tj plus 1. Look this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15 are times. P1 already filled these cars. P2 already filled. Okay, the remaining cars have the capacity is 9 and 15. Okay, now out of 9 and 15, which car will be sent to bunk P1, which car will be sent to bunk P2, so that overall time is minimized. This is 16 and this is 2 plus 4 6, this is 20. So sum of P1 so far is 16. Sum of P2 so far is 20. Okay, the next times are 9 and 15. Okay, so which one will be given to station 1, which one is given to station 2? What should be the logic? Say sum of P1 plus T1. Okay, what is T1? Suppose T1 is 15, T2 is 9. Okay, now how much it is? 16 plus 15, 31. What is sum of P2 plus T2? This is 20 plus 9, 29. So this is one option. What other option? Sum of P1 plus T2. This is 16 plus 9, 25. Sum of P2 plus T1. This is 20 plus 15, 35. Okay. So here difference is 10. Here difference is 2. Okay. Okay. So you take the case where the difference is less. If difference is less, T1 will go to P1 and T2 will go to P2. Is this clear? Otherwise, T2 will go to P1, T1 will go to P2. Hope you understand it. So we are going to write a program using this logic. So please listen to it very carefully. With focus. Thank you. See the capacities. The capacities of the cars. The capacities of the cars are, arbitrarily I am taking a problem. Let n is number of cars. Assume that petrol pump 1 has not filled petrol in any car. Petrol pump 2 has not filled petrol in any car. Okay. So P1, P2 contains amount of petrol filled in each of the cars. Initially, none of the cars get petrol filled. Okay. Now, assume that filled is false for all the cars. So no car got petrol for all the cars for I in range n. Once filled will not be filled. We fill only once. Okay. No cheating. So status is false for all the cars. Vijay Lakshmi, Chandi Priya. Did you join now? After 30 minutes? Okay. Filled is false. If filled is true, then that car is not considered for filling. So only not filled cars are taken for filling. Take 0th car first. Take 0th car first. Now while, let us come back to this condition later. Okay, because this is a repetitive process. Now take 4 temporary variables. Let A is the set of P1 values. All P1 values are copied to A. All P2 values are copied to B. Okay. Okay, this is for option 1. I told you that T1, T2. So what are the options? We have two options. What are they? P1 plus T1 is one option. Okay. P1 plus T1. This is option 1. What is option 2? P1 plus T2 and P2 plus T1. So two options. In the option 1, we find out difference. In the option 2, we find out the difference. We take that option where difference is less. Where difference is less, the waiting time is less. Okay. If difference 1 is less, then I allocate T1 to pump 1 and T2 to pump 2. Okay. If difference 2 is less, then I allocate T2 to P1 and T1 to P2. Is this clear? Initially, what I assume is, for first case, A is P1, B is P2. For the second case, temporary variables, C is P1 and D is P2. Okay. Is this clear? So here I check, this is what? This is A, this is B, and this is C, and this is D. I don't actually fill, I just check. If filled, what happens? Okay. After finding out what is the ideal pattern, then I fill. Is this clear? Okay. So I change A value, B value here. I don't change P1, P2 straight away. Here I change C value, D value. I don't change P1, P2. After finding out the best case, then only I change P1. After finding out best case, then only I change P1, P2 values. Hope you understand it. Aparna, Shravani, Shalini, let me know whether you understood this or not. After finding out ideal case, I change the values. Okay. This is checking what happens if filled, but actually not filled. Come on, please let me know. Okay, so let us have temporary list for testing. A, B, C, D are used only for testing, not actual filling, not for actual filling. Okay, if not filled, the current car and the next car. If current car and next car are not filled, then fill them. Okay. What are the options? You add jth car to A and j plus 1th car to B. This is option 1. Option 1. Okay. Find out the difference and find out absolute difference. For absolute difference, import math. From math, import FABS. Now difference 1 is absolute difference of total times of bunk A minus total time taken by bunk B. Okay. So this is case 1. Now case 2. C is P1 here. So dear students, please do respond. I feel that I'm teaching to myself. Same. C is P1 now. Add J plus 1 to this and 2P2 add J1 or J. Okay. Case 1 is J plus 1. Case 2 is J plus 1 J. Okay. Now find out the difference. Find out the difference. Difference is total time taken by all the cars at C so far minus all the cars at D. Actually, they are duplicate versions of P1 and P2. Now, if difference 1 is less than or equal to difference 2, then take option 1. Okay, difference 1 is less. What is option 1? What is option 1? To P1 send car number J. To P2 send car number J plus 1. Okay. Do it when first option is good. Otherwise, to P1 you send J plus 1th car. And to P2 you send jth car. Okay. After this, because J and J plus 1 got a petrol, change its status from false to true. Okay. So how long will it continue? Till till j is less than n minus 1. Okay, it cannot be less than n because j plus 1 is taken here, so it should be less than n minus 1, right? Now print all the cars, numbers of the car, times taken by all the cars at station 1. Say pump 1, load, print pump 2 load as well. Okay, and print total time taken by pump 1 and total time taken by pump 2. Total time taken by pump 2. Okay, so let us run this program and see. Hope no logical and syntax errors. Let us save this example. Parenthesis missing here. So one more issue. I think one more parenthesis here. So we should check line by line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15. N is total number. P1, P2 are empty. Field is false. Start from 0. J less than n minus 1. A1, P1, P2. AB, P1, P2. CD, P1, P2. If not filled, J and J plus 1. A dot append J, J plus 1. Difference 1. C dot append. If difference 1 is less than or equal to difference 2, P1 dot J and P2 dot J plus 1. Here P1 dot J plus 1 and P2 dot J. Field is true. It went into infinite loop. So there must be some issue with the conditions. J plus 1. Can you tell me what happened? I know what mistake I did. I'll wait for you to find it out. Everything is fine. One statement is missing. Can you tell me what it is? Laboriously typed all the rules, and all the rules are seems to be okay. Vijayasri, Dharani, Manisha, Pranita, Shalini, Shravani, Rakiba, Aparna. No. Okay. Everything is fine. One statement is missing. No problem with existing statements. No problem with existing statements. I try to find out. I am deliberately moving forth and back, moving forward and backward. Vijay Lakshmi, Chandu Priya, Aparna, tell me where we went wrong. So even 1 minute seems to be very good. Good, Shravani. We did not increment. We did not increment J. Very good. Still, there is also some issue. I thought everything is okay. Now, J equal J plus 1 should not be part of if statement. It should be outside if statement. Okay? Okay. Is this fine? But this is not ideal solution. This is not ideal solution. It is better than 25-35, but not ideal solution. So what should be done? If there are only 4 tasks, then it is better. 1 plus 4, 5, 2 plus 3, 5. Okay? And then up to this also 10, and this is 11. Okay? So to this extent, if there are only 8 cards, so this is perfectly alright. 1 plus 4, 5, 5 plus 5, 10, 18. This is also 18. Increment is done. Okay. So now the ideal solution is 29-31. The ideal solution is 29 and 31. Okay. I make a small correction here. Say I sort it in reverse order. Okay. And then I run this. So it is always better to take the last one first and do it. Is this clear? Is this clear? So let us do while printing we sort them. Otherwise you think that they are different. First sort and then print. P1 dot sort and P2 dot sort and then print them. Okay. Is this clear? Now I leave it here because this recording is available. Play it one more time and check. So what is the time now? It is 31 minutes. Okay. So what do you print? Time required. Time required is maximum of P1 and maximum of sum of P1 and P2. Sum of P1 and sum of P2. Okay. Instead of finding sum every time, we can store in some variable and print it. I think issue is with parenthesis as usual. Okay. Clear? So one more important thing I did is I sorted them in descending order. And then while printing I brought them back to ascending order. So you try this for different test cases and let me know. But while assigning, you must have them in one order, either in ascending or descending. Should not be random ones. Okay? And have a look at the solution as well. So hope you understood the purpose of taking 4 different variables. We made final change only when we are pretty sure that which one is good. Okay, so please respond. Time is running out. Clear or not? Okay, so one very interesting problem. Uh, Try to get the logic. We'll discuss in next class. This is y-axis and this is x-axis. X and y. Okay. We are given different line segments. This is one line and this is another line. This is one line. For every line, endpoints are given. Line 1, line 2, line 3, line 4 and line 5 endpoints are given. So that you can construct the line or you can get the equation of the line. Now a bomb is dropped. These lines are maybe line of barracks or line of houses or line of markets. Okay, a bomb is dropped. The impact of the bomb is at this point. The impact of the bomb okay, the bomb touched the ground at this point. Its effect is along a circle of radius r. Okay, it will destroy everything within this circle. It will destroy everything within this circle. Okay, is this clear? Did you understand the problem statement? These are different lines. Okay, the bomb dropped at this point on the ground and the bomb can destroy everything within this circle. The radius is given. Okay, now you need to find out the length of remaining line segments. You need to find out the length of remaining line segments. Okay, did you understand it? Okay, these are the remaining line segments. You need to find out their lengths and sum of total lengths. Is the problem statement clear? And this area is totally devastated. Nothing is available. Okay, so this is remaining line, this is remaining line. You need to find out L2, L3 length of remaining line segments, L4, L5 and Finally, total remaining lengths of lines. Is this clear? So you need to be good in coordinate geometry, analytical geometry to do this. This is a mathematical problem. This is more of aptitude problem than of coding problem. Okay. So try logic at home. It was asked in 2007, 2017, 2017 code vita. Okay. Okay then. Hope session went on well and you understood whatever was explained. Thank you. Bye.